Good morning. Thank you for joining today's webinar, Increasing Roadway Safety with Intelligent Flashing Beacons by Availed Technologies. My name is Connor and I'll be your moderator. Just a few housekeeping things to run through really quickly before we dive in. All phone lines are muted, so if you have any questions, go ahead and use the chat feature within your GoToWebinar toolbar. Presentation will last about 30 minutes or so, which will give us time for your questions at the end. And by attending today, you are eligible to earn TARP points through IMSA. If you provided your IMSA number during the registration process, Western Systems will go ahead and handle that submission for you. If you'd like a copy of today's slides, they are available for download within the handout section of the GoToWebinar toolbar. And lastly, today's webinar will be made available on demand. You will get an email tomorrow with a link to do so. All right, with the housekeeping out of the way, I'm very excited to introduce today's presenters, Jason Spencer, Territory Manager at Western Systems, and Greg Miller from Availed Technologies. Jason, the floor is yours.
Awesome, thank you, Connor. All right, hopefully everybody can hear me okay. I appreciate you guys joining us today. We're working really hard to keep things running business as usual this past month. One of our strategies has been to offer these webinars 2 to 4 times a week as a way to kind of continue to share information about our products and partners to everyone else who's stuck working at home. So if there's any subjects or products in particular you're interested in learning about, please don't hesitate, give me a call, shoot me an email. I'd be happy to set something up. Your feedback's vitally important to us. Our facility, our manufacturing facility is still fully operational. We've made some changes on the floor to make it, better to facilitate social distancing, but we're still maintaining our production deadlines. So a huge shout out to everybody up in Everett for, keeping the wheel turning. Before we get started, a little bit about us. Western Systems was founded in Everett, Washington in 2001. At the time, we were really only doing traffic signal cabinets for the state of Washington. We quickly found it beneficial to our customers to have a single provider who's able to supply all the equipment that you see on the road today. So we started providing everything from the cabinets to the controllers, central system software to detection. We've constantly been growing our product line to better serve the safety needs of our customers with RFBs, school zone flashers. We've connected agencies with radios and switches. And with our growing product line, we've grown our competence and expertise with the goal of being the one place our customers need to go from start to finish on their projects. As our product line has grown, so has our reach. So today we cover Washington, Alaska, Idaho, Montana, Oregon, California, and we've made it our goal to have a customer support-oriented business plan with a highly skilled technical support team that can take on any challenge you throw them. So today I'm excited to share the virtual stage with Greg Miller with Availed Technologies. Western's been representing Availed for about 5 years now, offering their flashing beacons and enhanced sign products to agencies up and down the West Coast. Availed has developed an industry-leading solar-powered product line that has passed the ultimate test in solar hardware, specifically working here in the Pacific Northwest, where it's not uncommon for us to go days, weeks, even months without even seeing the sun. Just a quick reminder before I pass it over to him, there is a little questions tab on the GoToWebinar toolbar. If you guys have any questions as we're going through this, feel free to enter those in there and we'll get those answered afterwards. So with that, Greg, it's all yours.
Hey, thanks, Jason. And thanks everyone for signing in here this morning. It's great to be here. And I guess I'll start with just a little background of myself and Availed. So as Jason mentioned, we've been working with Western Systems for the past 5 years. And we started the company and Western was one of our founding distributors that we've been working with. And we've been working with companies like them throughout the country and in Canada as well through that time. My background goes back to around 2001 in the solar LED space for traffic devices. And it's been a fun ride going through the changes in technology and how things have really, advancements in LEDs in particular have really enabled a lot of what we're able to do. The name Availed Technologies and the verb avail in particular, taking advantage of a resource or opportunity. And that's really what we're doing here with solar products today for traffic devices. LEDs, efficiency of LEDs, as well as improvements in solar, and we'll get into some of that in the presentation as well. And charging circuitry, optical efficiency, all those elements are really making the products far more powerful, reliable, and opening up a whole range of applications that were not possible back in those early days. And we've seen obviously changes in LED signals coming in mainstream, and what that means for products that are running on solar power. It's pretty important. So along with that, we'll talk about our LED enhanced signs as well as the solar flashing beacons. LED enhanced signs consist of either red or yellow LEDs. We also have white, but generally it's these two. And the LEDs are mounted, embedded into the corners or on the perimeter of the sign that you see here, in the corners of an octagon or stop sign, and then the corners and then the midway points on a diamond-shaped warning sign. In a similar configuration if it's a rectangular shaped warning sign. The premise here is really to draw attention to the sign, and having it flash draws attention to the sign when the conditions are present. So in other words, for a stop sign, you want them flashing continuously, or when a vehicle is approaching, and same with most of the warning signs that we have. So our applications are continuous flash, and then also vehicle activated that we'll get into. The range of signs, certainly stop signs and yield signs are stop signs are the most popular, stop ahead, signal ahead signs, but there's a whole range of things. As you can see, these are just a slight, small example of some of the different signs we do. So all the METCD signs, as well as non-METCD signs like this one in the bottom here, watch for vehicles or what have you. There's a range of things that we can do in that field. The LED sign itself is attached to the pole just down below. So our solar engine mounts to the top of the pole. The sign mounts to the side of the pole, and there's a junction box that we're looking at the back of the sign here on the right side, and this is how the solar engine connects to the sign. So very straightforward installation, and lends itself to a lot of flexibility if there's a different type of mounting configuration from your typical top pole mount solar and then sign directly below it. You can have them mounted that way. For example, if the signs are going out on a mast arm, or if there's a reason to have the solar engine up higher on the pole than where you want the sign, this approach lends itself well to doing that. One of the things that that drew us into developing an LED sign was the fact that they really are well proven as a very effective device, and still a lot of people don't realize the research that's been done here. So this research dates back, some of it's over a decade ago, and some of the research was done over long periods of time, and to basically rule out sort of any novelty effect of the device. And it was it's found to reduce the blow-throughs through stop sign or four-way or two-way intersections by over 50%. And then another study looking at right angle crashes and found a 40% decrease in that. So they have been adopted and are in use extensively in some areas of the country, and far less so in other areas, which is interesting. And that was one of the reasons that we decided to bring out the flashing beacon, because this device also has similar effectiveness. It's just a different approach to it. So instead of LEDs mounted around the sign, just a flashing beacon, either red. This kind of looks orange in this picture, but that's red. It's a traffic signal red. And red on stop signs or yellow on warning signs. And so obviously that device is used very commonplace throughout the country. And again, just bringing attention to the regulatory or warning signs. So the AV240 is the 24-hour flashing beacon. We have it for either red or yellow LEDs, either 12-inch or the 8-inch size. The housings are either yellow, black, or green polycarbonate housing. So getting into the solar engine design. So the solar engine is what we have that houses the control electronics, the batteries, and the solar panel. It's the brains of the system. One of the things, and this kind of goes back actually to some of our, our experience in this field, is understanding what are some of the critical components to the for the application. And number one is reliability. Number two is reliability. Number three is reliability. And reliability in terms of the system being able to run all year, and the system being able to run year after year, and basically maximizing the time interval between having to replace the battery. And one of the key elements to that, increasing that longevity with a battery, is to regulate the ambient temperature and keep that battery cool during hot conditions. Hot conditions, the battery will run efficiently, but it really can kill the lifespan of it. So one of the approaches, one of the main design features that we went with the product, the solar engine design, is to thermally isolate the battery as much as possible. So what we're looking at in here is this is the enclosure. The battery goes into the side door access, and then there's actually a vented lid, and then two bars that you can see here. And the solar panel attaches to those bars. And so basically there is an air gap. You can see it better in this slide. And so here are the two bars that attach the solar panel. We're looking at the side of the solar panel. This is the battery, by the way, in the lighter gray in the enclosure. So there's an air gap between the solar engine enclosure housing the battery and the solar panel. So the solar panel, obviously facing south, is absorbing the heat energy, and the airflow in between the panel and the where the battery is housed provides that really essential ability to minimize the ambient temperature. So keeping this this enclosure isolated from the panel and basically in the shade all the time, essentially, and also keeping it ventilated is really important for maximizing that lifespan. The other element that I just would like to mention on this stage is our design by having the solar panel mounted to these two brackets allows us to move the solar panel around in terms of size as things change. And it's interesting to see that, I'm sure in many cases, we sort of think of solar technology as pretty stable at this point for traffic devices. I mean, it's been out there for many years, but the technology is improving. And take a look at this. So just in the last 5 years, this is what we've done as a company in terms of our reducing the footprint of the product. So these are all, we've maintained a 20-watt solar panel. And we feel that's a real the sweet spot in terms of the power for this application. And we'll get into some of that in just a minute. But so keeping it at 20 watts, we've been able to reduce the footprint of the product pretty significantly over just the past 5 years. So that's an interesting, and like I say, our design, it really lends itself to being able to take advantage of those technology shifts. And so I said just now that 20 watts is the design, was the sweet spot for this application. And one of those things, and when we actually look at, and let's back up a little bit, but when you look at traditionally how solar devices and solar traffic devices are sized, we can look very carefully at the NASA solar insolation data for the, it's usually, we look at a 25-year average data. We look at the worst month, December, and we do some solar calculations based on that. And we add, we make sure our rate of load ratio, or the ALR ratio, is over 1, meaning that we're bringing more power in than we're consuming power during those winter conditions. And we're factoring in the location. So the solar insolation data obviously varies a lot if you're in Seattle compared to if you're in even Spokane, for example, or obviously south. There'll be very different solar conditions. But one of the things that I've certainly experienced in my time in the industry is that it's all fine and good to be able to put calculations on paper like that, but it really doesn't speak to the real world. And in the real world, even if it's in a sunny location, these products are going to be installed inevitably where there's at least partial shading, whether it's trees or buildings or even overhead wires and poles. There's going to be shading there, and those pieces, it's really hard to, it's impossible to model that, because you don't really know where the product's always going to end up. And that's why, at the end of the day, the best approach we feel is to build in overcapacity. Overcapacity allows the system to ensure that it's going to run through conditions where there's a partial shading, and B, it's going to enable the product to keep a really high state of charge. And I won't go into detailed slides on that, but just understand that with a lead acid battery, any battery technology, but particularly lead acid batteries, it's really important to keep them at a high state of charge. And so when you have products that are discharging the batteries by 50% or 70 or 80%, even if you can get through one season doing that, you're compromising the life of the battery. So you're reducing the battery lifespan is directly related to the depth of discharge, so the number of cycles that the battery will be able to maintain. We keep our products in the top 5-10% of state of charge all the time, even in winter conditions, and that allows us to get through and have battery lifespans that go 3, 5, and in temperate conditions that we'll see in the Northwest, they'll push the shelf life of the battery, which is 8+ years. So that's a big element of an approach to what we've done in terms of sizing and reliability. And the other thing that we've really, when we designed this product, a big focus of ours has been to look at from the perspective of the installation process and what's involved with getting this product put into the field. And so we've really designed everything. Every decision we've made at a product level has been to minimize installation time, and also to make the product as flexible as possible. So in this example here with the flashing beacon, we're using the standard signal hardware. And that's great because it allows some flexibility if there's requirements to mount this solar engine differently in a different location than this signal housing. For example, if it needs to go on a mast arm, again, if the signal housing goes on the mast arm, or if the solar engine needs to be mounted up high or on side a pole, or whatever the case might be, it's very easy to do that. It's very easy to utilize the standard signal hardware in basically getting the product, a standard product, applied to whatever location or application that is required. Mounts for the product. This is this mount here. You can see in the bottom here. This covers 90% of the applications with the same mount, which is handy. So it does both 2-inch square and 2 3/8 round. This, by the way, this slide, actually this title isn't quite correct. These mounts are the same for both products, the mount options that we have for both AV200, the LED sign, and the AV240, the 24-hour flasher. So we have 2-inch, 2 3/8 round covered by this mount. We have another mount that covers a U-channel. It also covers 2.5 or 2 1/4, for that matter, square or wood post. We have a 4.5-inch pole mount, and then a side of pole mount option as well. So all the bases are covered there. I touched on this earlier briefly. Radar activation. We're seeing more and more interest for this. It makes a lot of sense. And interesting, I haven't seen much research out actually looking at the effectiveness But I think intuitively, a lot of design engineers are looking at this and recognizing that having vehicle-activated radar systems can be really effective. And in terms of improving drivers' attention to signs. So as you're approaching, basically this product, I'll just skip to the next slide to see the device. We use the Houston radar, which is, I think most of the speed display signs are using this technology. Houston radar has a very nice device for integrating with other products such as ours. So we've taken this product and integrated to our system, built a bracketing system for it. So it's very straightforward to install. As you can see with a LED sign, it mounts just between the solar engine and the sign, just side of pole mounted. And basically what happens is it's a super low power device. It's aimed towards the approaching vehicles, and within the detection range is approximately 300 feet. And it'll pick up vehicles approaching the sign, and it'll flash the sign as long as the vehicles are detected. And so that's we're seeing that being used at stop signs or stop ahead signs, or curve warning signs is another application where this one there's a lot of interest and applications for that. So that's basically our product in a quick overview. And like I say, it's been a really exciting and rewarding experience being in this industry, and kind of seeing all the things that we've been able to accomplish with these products as the technology is improving. And we look forward to continuing to build out our product line and work with our partners like Western Systems, continue moving forward. So thank you very much, everyone. And I'll pass it back over to Connor here.
Yep. Thanks, Greg. We'll get going on the Q&A process. So if you have any questions, now's the time to put them in the chat there. And looks like we got a couple that came in during the presentation, Greg. So the first one is, can any SLA battery be used?
Oh, that's a good question. Yeah, and so one of the nice things with this design is it is a standard, it uses a standard off-the-shelf battery that can be sourced anywhere, so it's not proprietary. However, there is a word of caution. Not all SLA batteries are equal, despite manufacturers' claims. So we use the EnerSys battery series, and we recommend that that product be used. Other products will certainly work with the product, with our both AV 200 and 240, but the EnerSys product is our recommended brand. That's a good question.
Great. Another one for you. Should amp hours or watt hours be used to compare battery capacity?
Yes. These are some of the spec games that are played, I think, and amp hours really don't tell the whole picture in terms of the battery capacity. The energy storage or the power in the battery is watt hours, and watt hours is basically is simply amp hours times the voltage. But you'll see a lot of specifications out there that just talk about amp hours. And the details there are that not all systems are running on a 12-volt battery. So you really need to look at the voltage of the system times the amp hours of the battery to actually see the battery capacity. So always, yeah, always look at watt hours or do your calculations.
Got it. What is the difference between Availed solar charging technology and TAPCO?
Okay, so one of the things, and I'm not sure TAPCO specifically, but the charging technology, there's the difference between maximum power point tracking and then PWM or pulse width modulation. And MPPT is far superior charging technology. It provides optimum power throughout the range of solar conditions, where PWM is really more geared up for providing, it's really more designed for full sun conditions. So when you compare the two technologies in full sun, bright middle of the day conditions, they're not that far off. But it's those marginal shoulder conditions, either mornings or afternoons, later in the day, or during overcast conditions, where MPPT really stands out. And so that's a big, a big differentiator, if you will, between products that are out there is the charging technology. So if you look at, you can't just look at solar panel size, for example, and say, well, these products have equal charging capacity, because it's how efficient are you from bringing the power from the solar panel into the battery, and that's that's a big component to it as well. I'll touch on one other point while I'm thinking of it, and that's the solar panel technology as well. So we use the monocrystalline, high efficiency monocrystalline panels. Again, a monocrystalline panel compared to a polycrystalline panel, mono panel will have, even if they're both rated at 20 watts, a mono panel will provide more power in lower or more challenging conditions, kind of right in those conditions where you need it most. I mean, that's one of the things that when you get involved in these products, you recognize that on clear blue sunny days like we're having here today and this week, there's the systems should be all completely charged. It's those wintertime conditions, or when the sun is as Jason was saying earlier, it comes out only infrequently, that you really want to have the efficiency of the product as dialed in as possible to make sure it's going to be reliable.
All right, looks like the last one here. How does the system detect daytime and nighttime?
Oh yeah, this is good. I like questions because it highlights the things that I miss in my discussions here. So I've just backed up the slide looking at the just the radar picture actually. So in the back of our device, there's a window here. So we have a photocell, and the photocell is how we're detecting both daytime, nighttime, as well as ambient light conditions. So the system reduces the light output during overcast conditions. Your eye doesn't need to have as much, the light doesn't need to be nearly as bright during overcast conditions to appear to be the same brightness as during daylight conditions or sunlight conditions, of course, and even more so at night. And an LED sign is actually required by the METCD to dim down at night. And it's a really important energy conservation optimization is to be able to do that. We've put the photocell at the back of the solar engine. Basically, this will always allow it to face away from the sun, and that provides the most accurate way of measuring ambient light. So some other systems might be running off measuring the ambient off a solar panel, and that's less accurate for daytime dimming than running off of a separate photocell.
Great, that looks like all the questions we have today. So thank you everyone for attending, and have a great rest of your day.
Thanks again.